Alright, this video is over topic 1-1, translating and solving equations. And when we are solving linear equations today, we are only solving with one variable. So for the first example, we are asked to give steps and the reason. For solving one variable equations, you are always going to perform the opposite operation that is currently happening. For example, 1/4 and a are being multiplied. There's an invisible multiplication symbol in between those. So we are going to divide because we need that 1/4 to move to the other side. We can cancel it out. Hold on. We can cancel it out on the left side. So 1/4 times a divided by 1/4, 1/4 divided by 1/4 cancels. And on the right side, it's moved. So now instead of 16, we have 16 divided by 1/4. You can put that in your calculator and find out that a would equal 64. In order to check your work, you simply plug in the number that you just got. We just got 64 for a. And we see if that equals 16. So on my calculator, I can type in 1/4 times 64, and it does equal 16. So my work is correct, and a does equal 64. On problem 2, m is being divided by 3, so we are going to multiply to get rid of division. If I multiply by 3, whatever I do to one side, I have to do to the other side as well. So on the left side, 3 divided by 3 cancels, and I'm left with m. On the right side, -5 times 3 is -15. In order to check, -15 divided by 3. I always tell my students to double check on the calculator because sometimes we get these crazy thoughts in our heads where like 5 times 3 is randomly 16 or something. And it does equal -5, so I am good there. So always, always, always use that calculator to check your answer. On the third one, the first thing we are going to do is subtract 8 because we need to move it to the other side. My whole goal in solving is to get this d by itself, but I have to move whatever is outside the box, whatever is on the same side as d but not directly attached to d first. Remember, whatever you do to one side, you have to do to the other. That's the golden rule of algebra. So on the left side, I have 4d. On the right side, I have -24. My second step now is going to be divide by 4 because 4 and d are being multiplied. Whatever I do to one side, I have to do to the other. So d is going to be -24 divided by 4, which is -6. To check my work, I plug in -6 for d in my original equation and see if it equals -16. So 4 times -6 plus 8 does equal -16. So I got that one right. Problem 4, our first step, we are going to subtract 6 because 6 is positive. 6 is on the same side as c, but not directly attached through multiplication or division. So I box my variable and I do the opposite of whatever's outside. So in this case, we have 6 on the outside, so I subtract 6 because on the left side it will cancel. Whatever I do to one side, I have to do to the other, and so on the right side, -15 minus 6 is a -21. My second step is to divide by -3 because -3 and c are being multiplied, so I have to divide. When I divide, this -3's with the c cancel, so I just have c left, and -21 divided by -3 is a +7. Again, I suggest always checking on the calculator because sometimes we know the number is 7, but we forget to worry about our negatives. Like maybe we think -21 divided by -3 is a -7, and when you plug all that in, you'll see that you're incorrect. So on this one, we have a +7 for c, So we say 6 minus 3 times 7, and that is a negative 15. So again, I got that one correct. Problem 5, box my term, move the opposite, or move to the opposite side. Anytime you cross that midline, anytime you cross here, you have to cross by doing the opposite. So I subtract 16 from both sides, and 3/4 A would equal negative 6. 10 minus 16 is negative 6. And then I divide by 3/4 on both sides because 3/4 and A are being multiplied. In my calculator, I type negative 6 divided by 3/4, and the answer is negative 8. Keep in mind, anytime you divide by a fraction, your answer should always be bigger because you're taking a whole and putting it into smaller parts. So you're taking, if we were thinking about dollars, 6 divided by 75 cents, we would have 8 groups, 8 pairs of 75 cents each. So remember, anytime you have a big number divided by a small fraction, it's going to get even bigger. Problem 7, I box my variable and I subtract 7 from both sides because 7 is positive and on the same side as m but not directly attached. So on the left side, I have m divided by 3, and on the right side, I have negative 12. And then because m is being divided by 3, I multiply by 3 on both sides, and m equals negative 36. On problem 7, this one looks a little bit different because we have 2 sets of letters here. We have a negative b and a positive 5b, all on the same side. So for this one, I need to take negative b and add it to a positive 5b because they're on the same side of the equal sign. So I'm actually going to do this in a different color just so you can see what happens with everything else, where everything goes. 13 is going to stay the same, and 37 is going to stay the same. The only thing I'm doing is combining 5b and negative 1b. 5 plus negative 1, or 5 minus 1, is a positive 4. From here, I box my term and I'm ready to move. So I subtract 13 from both sides because 13 is positive and I need to move it. I have 4b left on the left side and 24 on the right side. I divide both sides by 4 and find that b is 6. On problem 8, I'm taking the number in front of my parentheses and distributing. Just like if you were to walk into McDonald's and say, I want 5 number 1s, they should give you 5 burgers, 5 fries, and 5 drinks. Here we have negative 0.3 being given to y and 5. So when you write it, negative 3 times y and negative 0.3 times 5. And the equals and negative 13 stay where they are for now. When we simplify, just to clean it up and get rid of my parentheses, this is negative 0.3y and this is negative 1.5, and nothing else has changed. From here, trying to get y by itself, I'm going to add 1.5 to both sides. So negative 13 plus 1.5 would give me negative 11.5. And then my final step is to divide both sides by negative 0.3. And we get 38.3 repeating. So we do the 3 with the repeating bar on top of it. Two last problems that we are asked to write an equation but not solve. So Melissa and Emily's age together is 26, Emily is 15, find Melissa. So Melissa and Emily together, total means equal 26. And then we find out Emily is 15. So instead of writing Emily, I'm going to write the number for Emily, but everything else is going to stay the same. So M, the plus, and the equals 26 is going to stay the same. Instead of E for Emily, I'm going to put 15. So Melissa plus 15 would equal the total of 26. 10 tells us twice a number, so that's represented by 2n. Is means equal, and then 18 is just 18. So 2n equals 18. Remember, twice means 2 times.